In this video, I'm going to show you how to take a set of data and from that data set calculate the sample variance and the sample standard deviation. So the first step is we have this set of 8 data points. The first thing that we'll do, and we have all of our values of xi right here in the first column, we'll take those and we'll sum them up. So when you sum them up, you will get a value of 40. And the first step is just calculating the mean. And so to calculate the mean, you take that 40, you divide by your n, which in this case is 8. So you get your mean is equal to 5. So that's step 1. Now we have 2 methods of calculating the variance and standard deviation of a sample. So I'm going to go through method 1, which is first. And that's how the textbook does it. And then I'll show you a simpler method, method 2, that I prefer to use. So the first step in doing method 1 is to calculate this value right here, so which is the sum from I equals 1 all the way up through the nth value, so all of your sample. So in this case, across all 8, you need to sum up the squares of the value of xi. So what that means is you take each individual value for xi and you square it. So the first value becomes 9, which is 3 squared, then 5 squared is 25, 81, 4, 1, 16, 36, and 100. So that's the first step of just squaring the values. And then your next step, and let's put this down here, our next step is to sum these, to sum the squares, which gives you a value of 272. So in our method 1, our first value is 272. So that represents the box that is the blue box right now, the sum of the squares. Then the next step that you have is to take the sum of your original values. So the sum of your original values, which I will now also put in a box, divided by n, and then you're going to square that number on the top. So what you have is you plug in the sum which in this case is 40. You square that value of 40, and then you divide by n, which in this case is 8, and that whole formula is over n minus 1, which is 7. So when you evaluate this, you would get a value of 10.29. So that is method 1. It doesn't require a lot of computations. It's just taking the values, squaring them, summing those, and then plugging the numbers in. So that's one way of doing it. Another way, and that will give you the sample the sample variance. A second way is being able to using method 2, which will be up here. Method 2 says that the sample variance, s squared, is equal to the distance from each individual data point minus the mean of the entire set. So taking that difference and then squaring that difference and dividing that by n minus 1. And so what we get when we do that is, remember the first thing we had to do was to find our mean, so our mean is 5. So when we plug in now, we plug in 3 minus 5 equals minus 2. 5 minus 5 equals 0. 9 minus 5 equals 4. And so you can continue this down, so you would get minus 3, minus 4, minus 1, let's see. One and then 5. So that's your distance from each individual data point to the mean. So the mean of 5. And one property of this, of any time you're taking each of your data points and finding the difference to the mean is going to be the exact center of that mass of data. So when you sum these values, they will all cancel out to 0. So the sum of this column will always be 0. And so as a way of finding the measure, instead of using that initial column, what you're going to do is you're going to square that column so we can find some way of interpreting the distance where there is an actual distance, not just a sum of 0. So we're going to take these points. So you take, for instance, this -2, and you're going to square that value. So you get -2 squared equals 4. And you go down the list. 0 squared is equal to 0. 4 squared, 16. 9, 16, 1, 1, and 25. Now when you have these values, you can get a valid sum, and so the sum in this case is 72. And so what you would do now is you would take that value, and now we have enough to plug into method 2. So using method 2, we have the distance squared, which in this case is 72, is our numerator. And then the denominator is n-1, where n is equal to 8, so our distance is equal to 7. So when you plug this in on a calculator, you will see that you will get the same value as we had above, 10.29. And so the next step is that will give you the value of your sample variance. The next step would be to plug in the value into the formula for standard deviation. And so here we have 10.29. And so that using either method, we can arrive at the sample variance. And now using that number, we can then calculate the S, which is standard deviation, which is equal to the square root of the variance. So S squared equals the variance, and S is equal to the standard deviation. So S, if we're trying to solve for the sample standard deviation, is going to be the square root of 10.29, which when you plug that in is equal to 3.21. And that is how you find the sample standard deviation. Just one quick tip is that if you are trying to do this on Excel, there is a really simple way of solving for both the variance and the standard deviation, and that's using these formulas. So equals STDEV is standard deviation, or equals VAR, and then you can put in the parentheses. And so these are the basic values when you just have a sample. Later on in the course, we'll get into populations, but just when you have a sample, these are the formulas that you would use. And inside the parentheses, what you put here is you put the range of data that you are trying to evaluate. So if we were in Excel, what we would do is we would highlight that first column that just contains the 8 numbers from 3 to 10. So in our first column, X, we would take this row and we would take this row right here and just select these cells, and everything that I just highlighted in yellow, that would be what you would select once you do the open parentheses. So you would type in equals STDEV, open parentheses, select that row, then close parentheses and hit enter, and you would get the answer to be equal to 3.21. And same thing if you did equals VAR and then selected that array, you would get 10.29. So that is the end of this video on how to calculate the sample variance and sample standard deviation.